as probably you already got, I'm from Italy. So yes, and more precisely from Cagliari, a little place here in Sardinia, southern part of Sardinia. Yes, this is where I was born, and so, of course, a beautiful country, you know. So I thought that it would be useful also to share with you a little bit of my education background. And so, yes, I'm an aerospace engineer. I graduated in Turin and Milan Polytechnic and at the University of Glasgow back, sadly, in 2010. So it is more or less 10 years so far. Yes, actually space was my one of my great passions. So that was my my choice for my education, and it was a great journey, full of exciting things, and that I already applied a lot, and I am still applying my everyday job. So right after graduation, I started to apply the other thing that I was really passionate about, and it was mainly software. Yes, so starting right after the graduation, I enrolled in a job in a company, Italian company, dealing with CFD. CFD, computational fluid dynamics, is something that has to deal with a lot of software development. For advanced scientific applications, basically, in this picture, you can see a typical application of CFD, where you want to evaluate how the airflow is shaped around a body of interest. In this case, you are seeing a drone, so a small drone flying that produces structures in the fluid around itself. So yes, that was my very first important approach with software development, and software was one of my other passions. So I started right there, and it was the perfect merging between my background, academic background, and the other passion, informatics. So yeah, I started from there, and you know, when you have to deal with this kind of stuff, you have to take care of many important things about informatics. You know, we already have the first question, a very important one, where Vanni 96 is asking, how did you learn to program by yourself after your degree? Actually, this is kind of interesting, because most of the times when you got out from your degree, you do have to learn a lot of things in your very first job. So in some sense, it's important to got that first job in a field that you like, and then learn on the job from your colleagues, and also studying by yourself. Of course, you know, you have to put a lot of effort in it, because developing software is not something that you can learn in one day. It has a lot of things that are really specific, and you do have to take care of a lot of stuff. In particular, in this kind of applications that I'm showing you, you have to take care of RAM usage, you have to take care of CPU loads, and so you have to design your software in order to take advantage of your computational resources appropriately. So that's really important. And you know, as usual, you get familiar with those things, applying them day after day, reading books, papers, and experimenting. This is another very important thing, experimenting by yourself, maybe in your spare time. And this is something that you will see, it will come back later when I will talk about machine learning. It's a key factor in the success you are gonna have when applying these kind of things. So, oh, no problem, Van. Thank you for asking, and please, let's continue to ask questions if you have some, maybe later in the presentation. So yes, another cool application of those things that I studied that was, I mean, really strictly related with both aerospace as well as software development is space flight dynamics. This is a picture showing Apollo 11 mission. And you know, all those orbital transfers you have to deal with when moving from Earth to the moon, those things need to be precisely computed, actually really precisely computed, and it all has to deal with software development again. Software development for optimization, software development for accurate dynamics. So, you know, you do have to take care of a lot of things also in that cases. And so software development in this field is something that allowed me to deal with cool stuff for space, like orbit determination, with orbit prediction, orbit propagation, and also re-entry dynamics. So, you know, in the very last part of a mission, you usually have to go back inside the Earth atmosphere. Sometimes you want to burn up everything in order to avoid arriving debris on ground. Some other times you need to land your satellite or your capsule, maybe because there are humans inside, maybe because there are things of interest inside. Then you do have to evaluate accurately the trajectory, the re-entry trajectory, and again, this is basically something that you do in simulation, meaning you do have to develop your own simulator or leverage a commercial one. In any case, someone has to have programmed that software. And so, you know, again, very accurate simulation, again, software development. So yes, in some sense, you know, I had the chance to merge these two worlds. On one side, aerospace, on the other side, software development. And that's something that I'm really lucky of having been able to do. And actually, this was my very first choice, you know, being able to apply those things, aerospace things, in software development context. So now let's move on, and yeah, now it's the machine learning time. Basically, a few years ago, more or less, almost 5 years ago, we needed to implement few things leveraging machine learning. At least that was a possibility. Back in 2016, we were right in the, let's say, middle of the explosion of deep learning with the recent breakthrough that were carried out at the time, and TensorFlow was just released to the public. And so we were in the position of evaluating if automating things using machine learning could constitute a good advantage for the company. So I got really, really interested in that thing. You know, maybe what captured my attention was the fact that you were aiming at creating something that was completely, you know, automated. It was able, at least that was the goal, being able to create and act in an autonomous way, performing choices even better than a human. You know, so that was, to me, was kind of, you know, magic at that time. And so basically, out from nowhere, I got so interested. I started more or less 5 years ago from scratch, meaning that I was not, let's say, someone that was already on the matter, on the subject. I was starting from scratch, of course, with my academic background and professional experience. You know, academic background, even if it was in aerospace, that specific experience, those courses, you need, in order to do them, you need to acquire a very, very important math and physics understanding and capabilities, also statistics. And so you do have all basic tools to take on things like machine learning. Machine learning is more or less all about optimization. You need to optimize something, minimizing or maximizing something. And so you have to be familiar with optimization processes. What are the gradients, descents, for example. So this kind of stuff was pretty clear to me, even starting from my academic background. Then, of course, there are a lot of things that are really important on the software side, meaning like attention for bottlenecks, leveraging CUDA capabilities to speed up everything. This kind of stuff are of course really specific to the field, but thanks to my previous experiences, professional experiences, I had the chance to develop C++, Fortran, Python, C, a lot of experience with the different programming languages. And so it was quite easy to start this new journey in machine learning. Okay, so now I started to study it back then. And now I'm really super happy to say that it has been years since I strongly pushed to put those kind of things inside my day-to-day job, because it's cool, but also and mainly because it works. It works on a lot of stuff. It's a very important advantage. It gives you a very important advantage in a lot of things. And so, for example, as you can see in this image, we are talking here about object detection and localization, for example. And of course, you need to do these kind of things. For example, to perform autonomous navigation. In this case, you are seeing a typical segmentation image where the algorithm is able to distinguish between the road, the sidewalk, people, traffic lights, buildings, and so on. So, these are typical things of the perception layer. So that layer of an entire autonomous function that is needed to understand the environment in which the car finds itself, or the robot in general, maybe the flying vehicle. So in order to do stuff, you need to understand what is around you. And in this context, specifically, this is computer vision, machine learning, and deep learning in particular, is something that right now is state of the art. Is the basic reference for every similar task in computer vision. So yes, I'm applying these kind of things every day now. And yes, at the end of the road, after these years, starting from that degree, and a lot of training on the job, a lot of effort on my spare time, I'm here, and I'm really happy to deal with this kind of technologies. So I believe this one is the last picture about the background. And yes, I thought about mainly academic and professional experience. So, but of course, there are also other passions that contributed to what I'm presenting you today. Because today I'm presenting you something that has to deal with the machine learning, reinforcement learning in particular, but it has to deal with video games. Yes, and so apart from studying, apart from having a job, yes, another passion was playing video games. This one,